it's hilarious how strongly he puts this. He says that he finds the way that we write code today literally disgusting, right? The problem is that we're using LLMs too much and completely relying on them, and we're not learning and we're not growing. People who invented LLMs, it's hilarious to me that they're the people that are saying that LLMs aren't the final solution and everyone else is not listening to them. Everyone, my name is Michael, and this is Nick. We're both best friends. We've been friends for a long time, and we've been programming for a long time and using AI heavily every single day since ChatGPT came out. And one thing that we used to do when we lived together is talk about AI for a couple hours straight. So we figured we might as well start recording our chats and just putting it out there on the internet. So if anyone else, does the same thing as us, we're creating content for people like us. Okay, so the thing I want to talk about is Jeremy Howard. So Jeremy Howard, he's the creator of the Fast.ai course. He's also, the creator of the first modern large language model. He's one of those long-time AI researchers that has fundamentally, foundationally changed the game in terms of technology and what led to actual large language model creation. So those are the people that I'm really wanting to listen to. And we were talking, even though I don't like Peter Thiel, we were talking the other day about his book.
We have to disclaim it because he's a fucking
He's a
he's a
lunatic.
little weird. He's a weirdo.
Yeah, I do have to disclaim it. I do like what was the book called that talked about contrarian thinkers?
0 to 1.
0 to 1.
It's an amazing book. Everyone should read it. If you can find it for free, do that.
Yeah, he doesn't need more money. So
Yeah.
what's funny to me is that the contrarian thinkers in the LLM space are the people who invented LLMs. It's hilarious to me that they're the people that are saying that LLMs aren't the final solution and everyone else is not listening to them. It's like, listen, guys, they're the reason ChatGPT even exists.
Yeah.
And you think that you know better than they do? They've been doing this. They built this. It's like telling Iron Man that, that telling Tony Stark how to go and improve a technology that he designed that you have no idea how to build. Right? To me, that's what it seems like. Anyway,
you go to him and you're like, Iron Man is stupid. You should have turned it into a whatever, something else, right? And he's like, what?
Or maybe he's like, hey, Jarvis really doesn't work in these scenarios, and I would have to build something else if I wanted it to work. And they're like, what? No. Jarvis will probably be AGI in 2 years. And we're going to bet our whole company on it.
Oh my gosh.
Listen, I built it. I know. Okay. So anyway, the thing that Jeremy Howard talks about that I think is really interesting is the fact that large language models are eroding our competence. So if you use, and there's studies that show this. There's the studies from Anthropic that show this, that people who didn't use AI and people who did use AI to complete something, let's say they're doing a new problem using a new programming library for the first time. Both groups of people, the ones who do use AI and the ones who don't, complete the problem, and then they go back and they're quizzed on the library or the information that they had to learn in order to complete it. The people who didn't use AI, they struggled more. They took longer to do it. But on the quiz, they score much higher than the people who did use AI.
Yeah.
And so now, if you ask those people to go do it again, right? Let's say you give them a similar task, and now you take away AI for both groups. The AI group is going to struggle. They have no idea how to actually do it. Whereas the group who did it without AI the first time, they're probably going to confidently go into this problem now and have a better idea of how to implement it the second time. Like, hey, here's where it didn't really work last time. I'm going to do it again and change my approach a little bit because I've learned.
Yep.
And this is a giant problem. And so, from the contrarian thinker point of view, it's like, hey, what is everyone doing? And what is everyone not doing? What everyone's doing is just trying to ship code with AI as fast as possible. And people are saying it's not worth your time learning how to code. It's because AI can do it for you. It's not worth your time reading your code. Steve Yegge is a huge guy saying this. Like, I don't even read beads. It's like, well, what if beads stops working and no one can fix it because no one knows how it works? Also, what if you want to go build a new beads, make it better? You don't actually even know how beads really works under the hood and what's
Yeah.
causing the problems. So how do you make it better next time?
It's also a question of like there's apparently companies are afraid of their token spend right now, and if it turned into a point where the latest model all of a sudden wasn't $200 a month, it was like 10 grand a month, and that's what they were wanting to charge for it, and the companies said no, but their developers can't maintain the code base anymore because they've been like, let's go 10 years in the future, right? All the people that used to code by hand don't, and all the people that came in since then have been vibe coders from the start, right? You are so dependent on these models subscriptions that uh, no matter what they charge for it, basically you have to say yes.
Yeah. Okay, and let's give another scenario. So Beads
Okay.
is open source, so maybe not the best example, but let's say like a Stripe competitor comes out and
Yeah.
they're fully vibe coded and all of a sudden it stops working. You can't invoice your customers, you can't get paid,
Yeah.
and you aren't able to fix it quickly because you don't know how it works. So maybe it takes you a month to go and fix your Stripe competitor. In that month, all of your customers are going to switch to Stripe and
Yeah.
you have lost all trust. So you might have built a successful startup, but now it is dead. And this is going to happen. You're just telling me that no startup ever is going to have software problems that's fully vibe coded and they're just going to be able to fix everything really quickly? No way. That doesn't even happen with software that's created by humans, right? Where every line of code was written by a human and reviewed by a human at some point, right? Even there, software has, you know, big issues sometimes that cause downtime for the applications. Um,
Dude, this relates to security too, because I don't know if you've seen the number of secure, like cybersecurity instances through the roof. Stripe is building those agents that kind of work on their code base all the time, right? What happens if you have an out of loop agent that can just do harm and someone just like accidentally loads it onto their dev machine and they have access to staging or production or a Teams chat where they can MCP chat with your SEO, your CEO and get on, you know what I mean? Like it just starts social engineering and doing malicious things. Like I don't know if
yeah.
we're ready for a world where people don't know how to fix things when they've just broken in a way that is unpredictable.
And
Um,
there was, yeah, so
yeah,
that's another example. If you don't know how your application works, how do you know that it's secure?
yeah, you don't.
You're completely relying on the large language model to tell you that it's secure.
Yeah,
Um,
and people are trying to solve these problems, right? And AI might actually be better at solving security issues than people, but that's not really the point that we're making or that you're
but
trying to make.
well, yeah, so I understand people trying to use AI, and I would do that too, try to get me to a certain point with AI. But unless I can go in there and review it, if that AI model has a gap and it doesn't know that it has a gap in its cybersecurity understanding, right? You're going to have vulnerabilities that it confidently tells you aren't there,
Yeah.
even if there's a tool that tries to solve this problem.
Yeah.
So,
And AI is traditionally bad at this too, right? Because it's deterministic. So it only does what you tell it. It only explores spaces that you told it to explore. If you're not aware of the cybersecurity problem that it's supposed to be finding, it's not enough to just say find all issues. That's way too vague for any success in any prompting strategy, right? We know this by default. So you're not going to have the only things you can protect against with agents in cybersecurity are the ones that know what they're looking for, and because you told it, right? So the scope of that is smaller than you would hope.
Yeah, and I think you still have to be able to, at the end of the day, look at the code and say, all right, all of my endpoints have an authorization class on it, and here's how that class works. And yes, this is enough for my use case to prevent unauthorized access. Um, anyway, so Jeremy
But you
Howard,
were bringing up Jeremy.
he's
Yeah, let's go. Yeah,
yeah,
let's go
he's
back.
talking about the problem, right? The problem is that we're using LLMs too much and completely relying on them, and we're not learning and we're not growing. So he's got a product that he's proposing as sort of a solution to this. And let me try and see if I can share Firefox.
Which, by the way, are you reading about him from Twitter, or like where are you finding this, or his
He
blog
had a
or Hacker
podcast.
News?
He did a podcast that I shared with
Okay,
you. Yeah.
okay,
Um, it was
that's cool. I want to
uh
listen to that. He sounds fascinating, dude. I when
okay,
we listen to smart people in these AI spaces, like I just get so much value out of hearing them think. It's
exactly.
amazing.
Yeah, me too. Okay, so I want to show you this. So this is their website. Solve It is what it's called. And it's based on this book called Solve It Method, which is let me how to solve it. Sorry. That's what the book is called. It's from 1945. So it's another one of those like eternal advice like hey, if you find some first principles, these first principles still apply 80 years later. Um anyway, let's see. So basically solveit.com, you have your own instances that you can create. So I can create my second instance here, click submit. And this instance, I'm still learning about it, but apparently it's sort of like a Linux box where now I can go to that Linux box and it has a Jupyter notebook inside of it. So let me actually join this
The one
one
that's
that
already
I've already
running.
created.
Cool.
Yes, exactly. And so then you create a dialogue name, and it's called a dialogue because you're going to have a dialogue with a large language model. So I'm going to select this dialogue, the advent of code. So you're doing problem one from year 2024. So that's why it's named this. If I select that, and you can see we've got a Jupyter notebook essentially, where my first cell was accidentally, I did it as code. So let's delete this one. So I said, hi there, I'd like to try doing an advent of code problem. You can see I set it as a prompt. So down here, you have code, note, prompt. So I can just do prompt now, and let's go to the very bottom here and just say, oops, hello. And we've got a large language model inside of our Jupyter notebook. So summarize the problem that I did and my method that I used. Okay, so I just wrote summarize the problem that I did and the method that I used. And it's able to look through all the cells of this Jupyter notebook above and read, you know, what I've done step by step. And the solve it method, I'm going to stop sharing now, is essentially you break down a problem into tiny, tiny pieces. And you want to visually see the output of each step. So if I have to turn a string into a list and then parse the list into two lists of integers, right? I don't want to write a giant function that does all of that all at once. That's not the ideal approach to solving really hard problems and to
Yeah, it's to
learning.
break it down. Yeah.
Yeah. So first, it's like, okay, if you've got a string, turn that string into a single list. Then parse it and look at the result. Okay, I had a string first, now I have a list. And that's what Jupyter Notebooks do really, really well, right? And data scientists use Jupyter Notebooks a lot. And I know that because I work on a team with a bunch of data scientists, data analysts, and they're really comfortable in Jupyter Notebooks and they do pretty much everything in Jupyter
Yeah.
Notebooks. But they don't
That
know
was
how to
one
use
of my
Git.
favorite classes in college, by the way, was data
Mm.
science and doing stuff in the
Did you
notebooks. Like
use
I learned
Jupyter
so
Notebooks? Yeah,
much. Yeah, we
right.
did
And
like
it's just like a,
statistics stuff, and I literally remember it was like one of the most fascinating classes I ever took. And we were just doing math. It was like,
yeah,
but it was like the way that it was being shown and how you could like run the algorithms over the data was really satisfying. So, yeah.
exactly. So the point that Jeremy Howard is making is it's hilarious how strongly he puts this. He says that he finds the way that we write code today literally disgusting. He is he feels gross physically when he thinks about the fact that we write code without seeing the output. We write giant files without doing like step by step and actually seeing what each thing does. And it makes sense when you learn that the right approach to something is to break it down into small pieces and see the individual components. And then you
Yeah.
go and look how people build really complicated software, and you see that they just do huge chunks of code without understanding anything, without looking at the intermediate results, and expect to, build code that works, and that you understand. So I think the contrarian viewpoint here is that we should all be intentionally learning and breaking down problems, even though we can hand the entire thing to an AI and it can just do the entire thing all at once. Uh,
Hmm. So instead of like building an application in like a week, you should build some pieces and keep it, I don't know, just, I don't know. Okay, so I have two ideas here. One is I still think you have to validate that the that reality wants the thing you're building, which I think is a big problem for startup founders and why they want to build fast. But I think once you get past that hurdle or once you've found like a desire for your thing, maybe you want to slow down and build it well. And that's a very different methodology, right?
yes, and I also think that slowing down, and let's say you have a new idea and you don't really know how to build it yet. It you're still using an LLM to help guide you through the process, right? You still have that prompt option inside of your Jupyter notebook. You're not just
Mm.
completely doing it by yourself, but you're breaking it down into steps and you're saying, "Hey, I'm going to try to iterate through this so I can really understand like what's happening." If you're building something new, you have to do this. And large language models just regurgitate stuff that they already know. So
Right.
if you're
Yeah,
if
they can't produce wisdom, right? They have to produce things they've seen.
yeah.
Yeah.
So one of the things that Theo from T3 Chat is harping about right now is that the way that we are building code or writing code has changed, because most of the tools that we use are built to write one project at a time, to build one application at a time. Because without AI, it's ridiculous to think that someone would be building three applications simultaneously. But with AI, that becomes possible. So all of the tools that we've built historically are not for doing three applications at once. So AI is going to have no idea how to build applications to write three projects at once. So we have to work through the problem ourselves. That's just an example, right, of how software has not closed the loop on every single thing that we need to build. There's not training data for the new types of software that we have to go and build and the new paradigms, right? Like when we were first building agent harnesses, there's no training data on how to build an agent harness. That's new, right? So using an LLM to go and do that is not the right approach. Anyway, the other key idea here is the visualization piece, right? So Codex runs and you don't have the diff up. You can't see what it's doing step by step. So when you break down problems into pieces and you can see visually what's happening, I think that is an integral piece into you and I, let's say we're going and building an application, we have ideas. We don't have the end state application in mind when we start building, right? We start building and we get ideas as we're building it. We get ideas how we can apply the things that we're learning and the tools and the building blocks of the application that we're building, how we can piece those together in new ways. And we take our ideas and we go to the agent and we say, hey, I'd like you to build this, right? But we're destroying that process that allows us to come up with those ideas when we hand all the learning over to the agent and we're just prompting it. So I think there's specific moments. I don't want to go write boilerplate endpoint code with myself, right? I'm not going to go do that with a Jupyter notebook. But if I'm exploring like a new area, something that I have an idea about, but it's not fully fleshed out, and I really want to explore the space and learn more so that I can solve a problem here. I think I need to take this Jupyter notebook approach so
Mm.
that it's the ideal sort of playground for learning.
Yeah. Um, yeah. So to tack onto this, I think, we had that discussion earlier in this call where we were talking about like, hey, maybe don't overly constrain the model, allow it to think for itself on certain things that maybe it's already doing well. Um, this relates because it's like, you don't actually want to hand away everything to the model. You want to give it, um, you want to, you don't want to hand over everything because you don't want to give away your desire to decide where you're going, right? And I think part of learning is part of that too. It's like don't stop learning just because you can get the model to do things that you would have done previously, without thought, right? Like still decide, okay, given that, how am I going to continue learning, right? Um, and I think that's what, like, as we hand things, I think this is going to be a continual pattern, but it's like as we hand more and more to the models, we want to decide what learning looks like now and then have that as something that we're chasing towards over time. And I think this is a
Yeah.
really cool example of that, where you're saying like, hey, there's going to be stuff you're going to run into where the model doesn't know how to do it, and that's an amazing opportunity for you to step down into a low level and understand where you're trying to go and build inside of your mind, and grow the space of wisdom that maybe is going to build something novel that doesn't exist yet,
Yeah.
and can add to that. That's a great philosophy, I think, for the world we're
And
in.
one of the problems with trying to create revenue in a business with code that a large language model wrote is if the model can come up with that code and write that code for you, it can also write it for somebody else.
Yeah.
So you have no moat. But if you're able to still come up with novel solutions that a large language model could not create on its own, that is also your moat. By saying
Mm,
like I know that another large language model cannot do this, because I tried and it didn't work. And
mm.
so then I stepped down and I created a new solution. And so anyone else who's trying to code with just vibe coding can't do it.
Yeah. Hey, let's bring this full circle and say that, in order to think of things that the model doesn't know how to do, you have to be a contrarian, because you have to think outside of the space of what exists inside of the models that know everything. So, like, this is just a further. We're digging into the same first principles, right? Where it's like, oh, you want to create something new that changes how things work now and does it in a better way. You have to think outside of the box. You cannot think inside of the LLM knowledge that exists because it's already been solved, right? And this is just how it is.
Yeah, well, it's funny again to bring this full circle. What I was saying at the beginning is it's funny that these guys who invented the first principles are the contrarian thinkers. Like, why is
Yeah.
first principles contrarian all of a sudden? It's like everyone's going crazy, and the people who aren't going crazy are contrarians. And that's what I was saying about
Wait, that's really interesting. Are first principles always contrarian?
I
I
don't
feel like
think
it's
they
pretty
should be.
common. They shouldn't be, but it's like commonly so. Like
I think people,
sometimes first principles aren't convenient, so then they don't fit into the like normie like world, right? And then they never
yeah, and
will.
that's what the myth of artificial intelligence is talking about, which is like there's all this sort of like religion around AI right now, where people are saying that AI is going to become a super intelligence, is going to basically become a god over humans, and we're going to have this singularity point where we can't see beyond it. But there is no evidence to support that that will happen because when you look at the first principles of AI, it's based on math. Math is incomplete, and we haven't solved those problems yet. So without solving those problems, it's unlikely to happen the way that people are
Hmm.
saying it's going to happen. We have to go and actually solve those core problems first. Um, and really, really smart mathematicians like Alan Turing and Gödel have tried to solve it and they can't.
Yeah. These
And
guys spend 20 years thinking about one problem and it's like never did figure it out.
yeah, and that
Mathematicians are
already
super, yeah.
these guys graduated college with a math degree at like 16 and then spent 30 years studying
Yeah.
math and still couldn't solve these problems.
Yeah.
And yeah, anyway, so yeah, to bring it back full circle, right? I think the method, the how to solve it method is a book from 1945 talking about like how to learn and how to solve hard problems. And when we try to think about like thinking out of the box, we're when I go and try to think of a novel solution, I go sit on my porch and like try to have a good idea, you know?
Yeah.
But
Same.
really, what I should be doing is breaking down my problem into small steps, seeing the results, and like learning that way. Because that's the proven way to solve really, really hard problems, not sitting on a porch and trying to solve it all at once in your head. Um,
Oh.
so
Well, I think sitting on the porch can be a good way for you to solve a small piece still. I don't want to throw that out.
yeah, I'm not saying that
But yeah,
that's you
but it's
shouldn't do
not
that.
some like, yeah, I see what you're saying though, where it's like, it's not some epiphany. It is the methodical approach of like adding one to this and being like, where does that take me? Okay. Am
Yes.
I getting somewhere? And kind of
Yeah.
like being active and engaged with the ideas.
Yeah.
Yeah.
And then go sit on the porch after that and think about everything that you just learned from doing that. But don't just go sit on the porch and never
Yeah.
do that. Right? Yeah. So anyway, that's what I wanted to talk about.